going on? Mr. Mac here. Just thought I'd talk a little bit about the events of things that are going on in the sky this week. First of all, the moon's been pretty dominant this week. Beautiful crescent going into the first quarter phase, into a waxing gibbous moon, into a wonderful full moon. Now, you've heard a lot about the moon on the news. It is a full moon. They use the term supermoon, but supermoon really talks about the fact that the moon is at its closest approach, in which we call perigee. The moon's orbit is actually an ellipse. It's an oval shape. So the moon can be as close as 235,000 or so miles and as far as about 250,000 or so miles away. So supermoon is just when the moon's really close in its orbit. But these are a series of shots that I took of the moon as it went through its phases. And the moon goes through its phases because it orbits the Earth. And based on the moon's position and the sun's position and the Earth's position and the time of day, that's how we get the phases. So now we're past full. The moon will actually be rising after sunset. And then when the moon hits that last quarter phase, it starts to rise at midnight. So you won't be seeing the moon being as dominant as it has been over the last couple of nights. All right, here's a picture that I took of the Pleiades and the planet Venus. You can see Venus is super bright up there in the upper left-hand corner, and then the open star cluster M45, also known as the Pleiades or the Seven Sisters. It's a beautiful open star cluster. Some of you might have read about it, but basically over the last couple of nights, Venus has been moving through the Pleiades. This picture here I took on April 4th. The night before, April 3rd, Venus was right in the Pleiades. Unfortunately, it was cloudy that night. These sort of events don't happen very often, so I feel pretty lucky that I was able to get a picture of it and share it with you guys. Now, the next series of pictures are pictures that I took right before sunrise, looking in the eastern sky of Jupiter, Mars, and Saturn. The first picture here was taken on March 25th, and you can see Jupiter and then Mars and the planet Saturn right there, Jupiter being the brightest. Now, all the planets orbit the sun. We are revolving around the sun. You know, the closer you are to the sun, the faster your orbit is. Mercury, 88 days, Venus, 220, Earth, 365, Mars, 687, and so on. So as you get further out, the planets actually move slower. So here you can actually see on March 31st, Mars has actually moved from in between Jupiter and Saturn, and now it's right there underneath Saturn. So being able to see that motion is what allowed scientists and astronomers to say, wait, hold on. Planets have to be orbiting the sun. They're not moving around the Earth. You know, Copernicus measured the motions of the planets. Kepler measured the motions of the planets to come up with their theories of planetary motion. This picture here taken on April 8th, just the other morning, you actually see now that Mars has moved to the left of Saturn. So again, Mars is moving really quick. Mars is closer to Earth than both Saturn and Jupiter. So it's been kind of fun to watch Mars switch places from March 25th to April 8th, going from in between Jupiter and Saturn to just below Saturn to now to the left of Saturn. Again, it just shows that our solar system is in motion. One of my favorite websites to find out what's going on up in the night sky is Sky and Telescope. It's a great website, and under the Observing tab, it talks about things that are visible in the sky and objects that are prominent. You can see where the constellations are, where the planets are. It talks about meteor showers. So this is a great resource. You can also look it up there. They have an interactive star chart, so you can find out where the constellations are. You can see events that are happening over the various months. So check it out. I figured I'd take some time and talk about some of the missions that are going on right now. So here's the Mars Curiosity rover. It's been roving on Mars for several years. These little rovers are like little planetary geologists, little robot geologists. This image here shows just amazing layers of the rock on Mars. And you know, we know that sedimentary rocks can be laid down in water environments, and this rover has shown us that Mars was a wetter planet at one time. It has just been a phenomenal mission. This image here is a high-resolution image panorama of the surface of Mars. So these rovers are just getting us prepared to hopefully get humans out there someday. So if you want, check out the Mars Curiosity rover on the net. A lot of really cool information, pictures, videos. A lot of the time, I think we just treat Mars like a scratch and sniff sticker. So, we keep doing the same thing. We're scratching the surface, finding out what's on the surface. But the InSight mission is a little bit different. This is actually the first time I've been kind of excited about a mission to Mars, because the InSight mission isn't there to take necessarily a whole bunch of pictures. It's there actually to be a weather station on Mars. It has a seismometer to measure Mars quakes, so seismic activity. And it has a thermometer they actually stuck in the surface of Mars to measure the temperature. So that's really what their hope is to use the seismic data to find out if the interior of Mars is still molten or not, or active. Maybe possibly could lead to volcanism or to maybe generation of magnetic field. So the first picture here is actually a picture or data from the weather station. So they're taking a lot of various weather data on Mars. Temperature, wind speed, wind direction, barometric pressure, just so we can get an idea of what's going on Mars weather-wise. So when we do send humans there. This next picture is actually an image of the surface from InSight of the seismometer on Mars. They've actually measured some earthquakes on the Martian surface that are about 3 to 4 in magnitude, so pretty good ones. And here's some of the seismic readings, the seismograms that the InSight rover or InSight lander has been picking up from the seismometer. Oh man, the OSIRIS-REx mission is a really cool mission. This is actually a mission to an asteroid, the asteroid Bennu. It's a really small asteroid. It's got a really weird kind of diamond shape to it, but the hope is the spacecraft's actually in orbit around asteroid Bennu right now, and their hope is they're gonna open up a little collector. If you look at the spacecraft there's that boom that comes out of the bottom of it, and they're hoping that they're gonna take that collector and just scoop some asteroid material off the surface, and then send that collection back to the Earth so we could study raw, untouched asteroid material, which is pretty amazing. Here is actually a picture of asteroid Bennu taken by the OSIRIS-REx spacecraft. Again, you can see that really interesting shape. It's not quite differentiated yet. They believe it's actually a loose pile of rock, just starting to get that gravity to bring it together. We talked a little bit about how electrostatic force, the positive, attraction to negative molecules, bringing the dust particles together, and then once you have enough, gravity brings it together, and then you start snowballing that effect to turn it into your planetesimal or early planet. Well, Bennu stopped forming right before that differentiation process. Gravity's still there, and then it stopped gathering material, and that's part of the reason why it has that shape. This image here shows high resolution image of the surface, and you can see it's just a collection of loose material. They didn't expect it to be this rocky, so they've taken some time to figure out where they want to do their data sample. So this is a really exciting mission that's happening right now. And a lot of Colorado connection to it up there at Lockheed Martin. All right, the next mission I want to talk about is the Juno mission to Jupiter. This is a pretty unique mission because it's actually the first mission to use solar panels beyond the asteroid belt. Once you get past the asteroid belt, the amount of energy from the sun becomes pretty low. Jupiter actually gives off more energy than it receives from the sun. But as the decades have gone on and solar panel technology has gotten better, we've been able to use solar panels out to Jupiter. Now, Juno is in a highly elliptical orbit. It goes really, really, really close to Jupiter and then goes pretty far out from Jupiter. Still within its gravity, but in very elliptical orbits. And the purpose is they want to get really close to the clouds of Jupiter. Juno is mapping Jupiter. It's mapping its atmosphere. It's mapping the motion of Jupiter's atmosphere so we can gain more understanding about how gas giant planets like Jupiter work. The issue is when you're really, really close to Jupiter, you're really close to that radiation from Jupiter, that energy that Jupiter is giving off. Jupiter also has a pretty intense magnetic field. So when you spend that much time in that radiation and that magnetic field, it can cause a lot of issues with your spacecraft's cameras and computers and things like that. So they get really close for a short period of time and they get pretty far out. But by being in those elliptical orbits, we can get really close and get just beautiful images like this one here. High resolution imagery of what's going on with Jupiter's atmosphere, the clouds, the swirls. When you look at it, it does have some similar features to Earth with the hurricanes and low pressure systems and high pressure systems. What you're seeing a lot is the energy within Jupiter coming up and reaching the cooler surface, almost like a boiling pot of water. Jupiter is a very, very dynamic planet. It actually has some of the most interesting moons in the solar system. You know, Io, Europa, Ganymede, and Callisto. Io being the most volcanically active, and Europa being covered in this layer of ice. And Europa is a very interesting planet or moon because it potentially could have liquid water, and we're very excited about that probability. And Jupiter is a very dynamic system, and you can see in these pictures just by the planet itself. Holy cow, just the resolution the Juno spacecraft has been giving us. All right, the last mission I want to talk to you with today is the Europa Clipper mission. Now, this mission is not in orbit right now. It is actually in the workings. It's in the design phase, but it's been given the green light to get built and launched. And the Europa Clipper mission is actually a mission to Jupiter to study the icy moons of Jupiter, mostly focusing on Europa. And also Ganymede. Ganymede is the largest moon in the solar system. It's larger than the planet Mercury. But you can see in this diagram, or the kind of the artist representation here of the spacecraft over Europa, you can see those lines, which are cracks in the ice, where they believe water from a sub-ice ocean has come up to the surface, forming new fresh ice. So this little cross-section of Europa here shows you the rocky metallic core, and then the rocky layer, and then that liquid water layer, and then the ice. They believe that Jupiter's gravity stretches and pulls Europa, keeping the interior of Europa warm. This is the reason why Io is the most volcanically active. But with Europa being a little bit further from Jupiter than Io, it's a little bit colder. So that's why you can have that layer of ice around it. And that layer of ice would actually be a really good insulator for that liquid water ocean, which is kept warm, potentially by sub-ocean volcanoes. So it's a very intriguing world that could potentially harbor life within our own solar system. So hopefully in the next few years, we'll see this mission launch and head on out to Jupiter and maybe find our first life beyond the Earth. Y'all have a great week. Keep looking up, Falcons.